This is the answers for Tuesday night's homework about how to find the inverse. We're actually going to go through each of these just to make sure we're good. This is one of those things that I like to go over pretty thoroughly. We're going to do something similar today, so the notes won't be too long. But I'm going to go through this pretty thoroughly. Some of it I'll go through pretty quickly because it should be easy, but overall, pretty thoroughly. So we're going to start with 15. We're going to find the inverse. X and Y switch places. So it's x equals, and then I'm going to solve for y. So I would start by minusing 5 from both sides. And then I'm going to divide everything by -2. So what I get is, in front of the x, I'm seeing 1, so it's a -1/2 x. And then 5 over 2 is a positive 5 over 2, or you could say 2.5. And that's the inverse, that's -1 of x. And then we want to sketch a graph of both of these. So we're talking about 5, the slope of -2, 2, 3, 4. So it looks something like this. And then 2.5, that's right here. And it goes down 1 over 2. So it goes something like that. And so this is the inverse. This is the function. And if you draw that y equals x line, that passes right through diagonally. There you go. Let's go to 17. And I'll do this one pretty quickly because 17 is about the same. Well, I guess we both are reciprocal. I'll go ahead and do the whole thing real quick. So it's -1/2 y plus 4. So then I solve for y by subtracting 4. And then I have to, let me get rid of -1/2. Negative times a negative is a positive, so I'm going to multiply by a negative. And we're going to do the reciprocal, so I'm going to multiply both sides by -2. So it's -2x plus 8. We're multiplying it by both. I distribute, okay? So that's my, let's label it as my inverse. This is my inverse. So if I sketch a graph of both, I have a y-intercept of 4. I'm going to go down 1 over 2, down 1 over 2. So this line would look like that. And then this one starts up at 8 and goes down 2 over 1, down 2 more over 1, and it's going to crisscross right about there, which again, if you draw the 45-degree angle line, that y equals x line that it's symmetric about, you can see the symmetry, how it mirrors itself on both sides. It's mirror image. Alright, so let's get to this one, 23, where we have it squared and we have condition. Now this is just like the condition that we saw in our second example, the answer to the second example, but notice this one says less than 0. It says less than 0, okay? So let's just start by finding the inverse of 23. Y, it's really like saying y equals 4x squared. This is just the condition. So I'm going to switch x and y. That makes my inverse, and I need to solve for y. So I'm going to start by dividing by 4. So it's x over 4, or you could say 1/4 x equals y squared. And then I'm going to take the square root of both sides. That's how we get rid of squares. So y equals, and I can simplify this. The square root of 1/4 is 1/2. Square root of 4 is 2. And x is still inside, so that can be simplified. And normally when we do square roots, we do plus or minus. That's where this condition comes into play. It only wants us to do it where it's less than 0. So let's look at the graph before we finish our algebra. 4x squared is a parabola. It's just been stretched. It's a regular looking parabola. Something like this. But they only want it when it's less than 0. So they don't want the positive side of that. Let me draw a better parabola. They only want where it's less than 0. Not the whole thing. Not the greater than part. So which part would be symmetric to that? Or which one would match the negative side? Well, of course, is the negative, so I don't want positive. I only want negative 1/2 square root of x for my inverse, not plus and minus. If there's a condition, you only pick one of the two, whichever one fits. In this case, I'm going to do the minus. And the minus side would just look like this. All that means, think about that transformation. It's a reflection. The negative on the outside is a reflection, so it's just going upside down. And there's the symmetry. Okay, that's probably the toughest one. Okay, so let's go to 25. So I would say solve this by switching x and y. And then I'm going to get rid of the cube by taking the cube root of both sides. So I have the cube root of x equals y minus 3. And then I'm going to add 3 over. And that's it. There's my inverse. That's all there is to it. Okay, there's no endpoints in this. Cube roots has no stipulations or anything. If I were to graph this, and maybe the calculator can help with that, but that's a cube root function. Remember the cube roots, it's been a little bit, but they go like this. They have that wiggle in them, that little wiggle in between. I'm moving this right 3. I'm moving right 3, and it's that with the wiggle. This one, look at the transformation here, this is up 3. So I'm going to move my cube root function, which looks like this, up 3. So here's my center point at 3 and at 3. And again, I'm just doing a semi-accurate sketch. And then look at it. Yeah, it's perfectly symmetric. Okay. All right. Number 27 is almost the same as 23. The only difference here is that this is asking us to do greater than 0. So I only want the positive side of this graph, not both sides, just the positive side, because I want it to be greater than 0. Which means I only want the positive of the sideways parabola. Okay, so when we do plus or minus, I only want the plus. And that's pretty easy solve. That's going to be 1/2 x, and then we take the 4th root of that, and I just want the positive of that. So that's the inverse right there. And solving should be relatively easy. But we only want the positive because we want it to be greater than or equal to 0. Now 37 is the one you need a stipulation for. 37, we're going to switch. This is like y, so we're going to switch x and y. X equals the square root of y plus 4. I'm going to square both sides. X squared equals y plus 4. Oops. There we go. And then I'm going to subtract 4. And that equals y. So I have x squared minus 4. And again, this is a full parabola. So we've got to think about what this graph looks like. That's a terrible graph. Let me put the graph over here. So we're talking about a full parabola. So what, hold on 1 second. So what does this graph look like? So this is a square root. Looks like this, and it's been moved left 4. This is a quadratic, and it's been moved down 4. But again, look at it. What do I need? Which part do I want? I only want the one side of it. Okay? So this has been moved left 4. This has been moved down 4. I don't want this back side of the parabola. The left side is not part of the inverse. The inverse is only the one side of it. So what is that stipulation? I said it's h, and if you look at the inverse, h, here's the inverse, h is just 0 because there's nothing inside. Look at it. What is the x value that I cannot go past? Because if I go past it, it's going to give me the other side, and that's an x value of 0. So simply saying x is greater than or equal to 0 is all I need. Similar to what these guys had in their original problems. Okay. And then 39 should be pretty easy. Let me just give you the answer here. So we would divide by 2 and raise it to the 3rd power, and add 5. So, and I would even say, let's do 1/2 to the third power, so 1/8 x to the third plus 5. So that's the inverse f negative 1 of x. And again, the cubed roots look like this. And I moved it up 5, and just shrink. I mean, the cubed roots would look something like this, going up and down. X cubed would look like that going up and down. The cubed root, this one moved right 5. So there's that point that's symmetric. These 2 points are symmetric. And then it goes left and right. Cubed root does. And here you can see the symmetry. So it's just all about knowing what the parent functions look like. You're just drawing sketches of it. But I'm mostly focused on algebra here, more than the graphs. But just having an idea of being able to sketch those, look at those graphs look like. We're going to do some more with graphs today. All right, go ahead and go to the other video where we talk about the notes for today.